Hello and welcome. I'm going to start a video series on embedded C. Don't worry, it's related to the 8051 and other microcontrollers. And so this very first video is an introduction. So let me first of all very briefly describe the difference between C and embedded C. Now, C is a general purpose procedural programming language. In general, the standard C is used for desktop computer applications. Now, embedded C is targeting really microcontroller-based applications. And it includes extra features, for example, input-output hardware addressing. And it also generates files like a hex file that can be programmed or burned to a microcontroller so that it can be executed. Now, let's talk about the prerequisites. Now, this video series, I'm going to assume that you have no programming or no prior programming knowledge at all. So no worries. And secondly, I'm going to assume that you have watched my video 36 on IDE Kyle Microvision. If you have not, it would be really helpful if you have watched this. And I'm going to assume that you have already installed Kyle Microvision on your desktop computer or your laptop. Okay, let's begin. And here we have what I call the simplest C program ever. All right, so this is the C program, and this word here, hash include in green, is known as the preprocessor directive. Now, the preprocessor directive is a step that is performed before the actual source code, which is this one here, is being compiled. However, it is not part of the compilation. So, and what we're trying to do here when we try to compile the program, the preprocessor commands are executed first, and then the program gets compiled, which is this part here. This is the main part of the program which gets compiled. Now, what this here means is it says include this file. So what is this? What is this file? This is known as the header file. It contains information that is required by the main program. We'll come to that in a few moments. And this word here, main, with the open and close bracket, that is known as the main function. Now, in all C program, you must have this main function. All right, it's a must. Any C program that you come across must have this main. And then finally, these brackets here, which I call curly brackets, or some would call it curly braces, that actually tells us the code of the block of codes that has to be included between the curly brackets. Now, in this particular example, there is no code. There's nothing. Okay, so we're now in the Kyle IDE. I'm going to lead you through the simplest C example that I've shown you earlier. So let's go to project, choose new microvision project, give it a file name. So it's asking for a file name, so I'll call it simple C. and click save, and this box will pop up and go to software package. Just click on it, drop down menu, select legacy device database, and then here in the search box type AT89S52, and it's under microchip. Select it, click OK, and now this message pops up. It says copy startup.A51 to project folder and add file to project. Previously in the machine code, when we were writing assembler we click no, but for C programming we click yes. So we click yes. Already exists, override, yes, and go to the project panel, click on the target, and then source group 1, and click, and you see now it's included the startup.A51 file. Now we need to go to file, select new, and you get this text box, and this is where we'll type in the program or the source code. So first is include, remember is the header file is RG52. Notice I've used all lowercase, that's okay. Notice it's all in black at the moment, so let's save it first. So save as, in this file name box just type simple C dot C, because we are writing it, the code in C, so it's .c extension. Save. Notice all the text now is color coded. That tells us that it's been saved as a C file. Now that's not all, so we click on source group. Alright, click on source group, right click, and then select add existing file to group. Okay, select it, and just type simple C, and the drop down give you a suggestion, and the file that we need is simplec.c, which is the one that we saved earlier. So we select that and click add, close this. Notice the simplec.c file is now included in the source group. Alright, so let's carry on with writing the code. So I'm going to do exactly as what we discussed earlier. So main, open bracket, close bracket. Notice the it's highlighted. It just shows you that if I just put some space in, so that tells us that this bracket is in line with this closing bracket. So that's why it's highlighted. Let's put it back together. Now enter, we move on. So remember, we need to have curly brackets. So open curly brackets is red in color. And then I'll choose to put the closing curly brackets down. So I've typed it. Notice it's highlighted. That's to show that this curly bracket and let's put a space in between, click on it. So that shows that this is should be in line with this. Alright, so it's a pretty convenient feature if you have a long piece of code and there are lots of these curly brackets around, so that will help. Okay, let me just take the space out. It doesn't matter, you can leave the space in, but for this example, I just take the space away. Now, let's save it. I'll choose to use save all, so it's saved now. If you have done some editing, let's just do some editing, alright? Okay. Notice there's an asterisk at the top. That tells us that editing has been the source code has been edited but not saved. So if we go to save now, save all, notice the asterisk is now disappeared. That is to show the file, the edited file, this file here is saved. Okay, so now that we saved the program or the source code, let's go to project, select, and then select build target. And if we, let me just zoom in here, you see there's 0 errors and 1 warning. Now, how do we resolve this warning? Errors are more serious cases, but warning, you can still run, you can still execute the code, but we want to get rid of this warning. So let me just turn off the editing mode. Right, okay. So there's 2 solutions. The first one is to type void in front of main. Notice it's in blue. Save that. And if we go to project again and build all targets, and you notice that it's now 0 warning, 0 errors. Now this is because when we declare this main as void, what we're saying is the code itself, the main function itself, is not carrying out any computation and it's not returning any values. So if we put void in front of the main, it will resolve the warning. Now the other solution is to, between the curly brackets, by the way, there's an indentation. I usually would like to indent 3 spaces, 1, 2, 3. Now you could choose to indent any space, but I choose to. So return, type return with a 0 and semicolon. Now save the program and now go to build target. Again, no warnings. Alright, so there's 2 ways of resolving the warning for this particular case. That is because the main function is not carrying out any computation and it's not returning any values. Now let me just take this out. I just want to explain something else. Save it. Now the way that the code is laid out, the way this code is laid out, is not mandatory. It's not compulsory. Let me just show you something. If I just put everything on one line, all right, let's put everything on one line and see what happens. Save it and go to project and then build all targets. Yeah, you see it's 1 warning because of the return and void. Let's ignore the warnings. You see, it will still compile. So let me put the code back. The way the code it's been laid out, well, it's just a convenient way of laying out the code so that it's easier to read. Now, just one more thing. Some people would like to put this opening brackets here and leave the closing bracket down in the next line or whatever line the code happens to be. But I choose to have it this way so that it's easy to identify the corresponding pardon me, curly brackets. So if I do it this way, it's more convenient. You can see it immediately. This curly bracket and this curly bracket belong together. Okay, before I end the demonstration, I'd just like to point out to you, if you notice that there is no instruction whatsoever in between these 2 curly brackets. So this code, the whole code itself, doesn't do anything. It's just for demonstration purposes. Okay, so we now come to something called program constructs. So what is program constructs? Program constructs basically determine how instructions are executed. There are three well-known program constructs, and they are sequence, selection, and repetition. Uh, for this video, I'm just going to consider sequence, selection, and repetition will be considered in my future up and coming future videos. So let's take a look at sequence. Sequence basically shows us that the statements in the code or in the program are executed one after another, as shown here by this flow chart. Here we have statement or statements executed. The next one, statements or statements executed, and same here. And you notice there are no condition attached. The statements are simply executed one after another. Here is a code fragment example. Here we're assigning 55 hexa. 0x in C programming is denotes hexa. So assign 55 hexa to the variable P0. Similarly, we have AA hexa, assign it to P1. Here we have 01 hexa, assign it to P2. Notice these four instructions are enclosed within the curly brackets. Okay, so here we have a complete code, very similar to the one that we've seen earlier. So we have include reg 52.h. This is the header file. So the program needs to include the information that is in the header file during compilation of the code. And void, here the word void means this main function or do not carry out any computation or calculation, and so it will not return any values at all. So that's why it's called void. We will see a lot more of this in the near future in my videos. So here, very similarly as we have discussed earlier, so we assign 55 hexa. Remember 0x here tells us this is a hexa value or hex value. Assign this to P0. P0, by the way, earlier I called it a variable. It's actually port 0 of the AT89S52 microcontroller or the 8051 microcontroller. So we're going to assign 55 hexa to the port 0. Here, similarly, we're assigning AA hexa to port 1, and we assign 01 hexa to port 2, and lastly, we assign 80 hexa to port 3. Now, all these addresses of these ports are defined in this header file. All right, let's take a look at it. So the header file or the device header file, reg52.h, they could be uppercase or lowercase. It doesn't matter. So the casing doesn't matter in the header file. So this is known as the device header file. And you see I've mixed here. I put them in uppercase here, but I refer to the file in lowercase, and they are exactly the same. All right, so let's look at a portion or partial content of the header file. Here we are. As you see here, we have the special function registers being defined in the header file. So srf p0 given the value or address 0x80 hexa, Similarly, P1 is 90 hexa and so on. Now these, as you recall in my earlier videos, these are special function registers addresses. So here the header file define all this for us. So all we need to do is in our C program code, in the main program, we just used this destination P0, P1, P2, and the compiler will know the addresses of these ports. Okay, so we're back in the Kyle IDE, and for this second demonstration, let's first create a project. As a reminder, whenever you write a C program with Kyle IDE or whatever other IDE, you often need to create a project first. So we go to the project tab. So, and then choose new microvision project. And you need to give it a name. I'm going to call it demo 2. So spell the 2 out. And the extension will be added for us is .uvproj or uvprojx. So all we need to do is type in the name of the project and save it. And another dialog box will pop up. And here we go to the software packs. We pull down the pull down menu. Look for legacy device database, click on it, and you will get a whole lot of devices that's available. Go to the search box, type in AT89S52. Now, I'm choosing this chip because that's the device that we use quite often, or I used it quite often. You may choose to use some other devices, it's up to you. So I've chosen this, I click OK, and it comes up with this message, copy startup.a51 to project folder and add file to project. Now, previously when we were writing programs in machine code, we would just say no, but since we're writing in C, we're writing C code, we need to click yes, and then another message pops up. It says file startup.a51 already exists. Override, yes. And now if you turn over to the project panel, expand the target folder, and the source group folder pops up. Expand it, click on the plus sign, and you will see the startup.a51 is added. Now we need to go to File, select New, and the text editor pops up. Now this is where we are punching the typing the code rather. Now my typing is not that good, so I'm going to copy it from a different file. The code. Just give me a minute. Yep, back with it. Then I'll just paste. Notice, notice everything is in black. So, and then there's an asterisk here, right? That tells us this file is not saved. So, but this is the first time we're saving it, so we need to give it a name. So we go up here. We say choose save as. I'm going to call it demo. Wait a minute. Yep, demo 2. So demo 2 there. And this time my extension is .c because it's a C code file. So it's .c, and press and then save it. Notice now it's color coded. That means it's saved and there's no more asterisk. Now this file, this is just a text file. It's standalone. It's not been included in here yet. So we need to click on right click on source, right click, choose add existing files to group, And then in the dialog box for file name, just type demo. And you see it's here, demo2. It gives you an option. You select demo2.c, click add, but watch out, watch the project panel. You notice the demo2.c is now added, so you close it. So now it's added, so we need to go to save or save all. I prefer to use save all, so it's done. But now we go to debug. No, sorry, no, we still need to go back to project. Now we need to build target. Click on build target, and it's 0 warnings. Oh, it's so far so good. Now, I'll come back to this in a minute, right? Okay, so, right. So I want to single step through this program. I want to single step the program together with you. So go to debug, start, stop, debug session, evaluation mode, click OK. And a whole bunch of stuff appears. We're interested in this with the source code. Notice it's ready to run, but I'm not going to run it. I'm going to single step it. Before we do that, these are all the ports. So we need to go to peripheral, I/O ports, got port 0, and port 1, maybe I should put closer, then peripheral port again, port 2, and then finally port 3. So we got all the 4 ports out. Now I'm going to single step. So I'm going to use F10 on my keyboard. So this will assign, this first instruction will assign 0x55. 0x denotes that this is a hex value. Maybe I just should zoom in. Let's see if we can do that. Yeah, okay. You just hold on the control key and then turn the mouse wheel and it should expand. So now, okay, so we're going to copy this value 55 hexa to P0, which is this one here. Let's see what's happened. Yeah, so in binary, this is 55. Now, port 1 is here, so we're going to copy AA. AA and 55 are the opposite of each other, so we should see an opposite pattern appearing in port 1. Yep, it does. So port 1 is a complement of port 0. Now I'm going to copy 01 hexa to port 2, P2, which is this one here. Right. Yep, it's 1. Everything is 0 except for this bit here, least significant bit. Then port 3 is the other way around. It's the other end that is 1 because it's 80. So let's see. Yep. So it's 80. Right. So this is just an example of sequence where each of these instructions is executed one after another with no condition attached to it. All right. So that's an example of sequence. Now, I would like to demonstrate something here. Yeah, a couple of things. Notice everything is within the curly brackets. All right, so if I click on this top curly bracket, it tells me this is the corresponding bracket that goes with this open bracket. And the code that we need goes in between these curly brackets. All right, now, come back that in a minute. Now, what I would like to show you, okay, never mind. Let's get out of this debug. So we stop the debug. Notice after we compile build, there's an, if you notice the C file, there's a plus sign. Now, if you click on that, it will expand it, and you'll notice that the reg52 file is included, because we have told, using the directive include, preprocessor directive include, this tell the compiler to include this file when you compile. So it does. So now let's check out what's the contents of reg52. I've shown to you part of it, so let's click on it. There we are. These are all the registers with the appropriate addresses assigned to it. So let's go to the special function registers, SFRs. So there are 4 I like to highlight, which is the one that we use in the program. So this H file, rather header file, defines P0, P1, P2. So that we just need to refer to P0, P1, P2, P3 in our code, and it will be recognized simply because we have declared it in this .h file. Alright, so it's convenient for us rather than try to memorize the address of the SFR. So that's the include part. Now void. Why is it void? That is because this function main does not do any computing at all, and it's not returning any values from the calculation. It's not doing it. So it's simply a for instruction which execute one after another. That was it, and there's no calculation involved, no return of values. So that's why because we said it is void. Alright, so now before I end the demonstration, let me just show you to repeat what I said. I'm going to put everything on one line. Just give me a minute. So I'm going to put everything on one line. So I'm going to save it, and I'm going to compile it. So rebuild all target files. No complaints. 0 errors, 0 warnings. And let's do the debug session part. For this one, I'm going to just run it. Alright, I'm just going to run it. So I'm not going to step through them. And you see, it runs. It gets executed. The point I'm making is, let me just turn this off. The point I'm trying to make is that you can put everything on one line, right? You don't have to do what we've done normally when you see a C program in this layout. Let me just put everything back. 1, 2, 3. Okay. All right. So, and got this. All right. This is called the code layout, and generally people follow some kind of a layout, and it's very, very similar to this layout here. This is so that people could understand it better and can read it a lot better. It's a lot tidier. Rather than put everything on one line, that would be tough. All right. So, okay, that's it for this demonstration. Okay, so we'll come to the end of this particular video, which is an introduction to embedded C. And as usual, I provided the code that I've used for the demonstration, and you can find it in the link in the description below. My next video on embedded C will be on selection. So see you then. Take care. Bye.